Alrighty, thank you. Thank you, Sam. I'm going to tell you the story of an Australian icon that hit hard times and found its way back again. I work for MYOB, the famous Australian accounting software company, and a few years back, we found ourselves in a bit of a pickle. So to give you a bit of a background, MYOB has been around for a long time in software terms, since the 1980s. Our flagship product, AccountWrite, is a desktop application that has been around for most of that time. It has a very deep, rich, mature set of functionality for small to medium business accounting. Now, in the 2000s, it looked like this internet thing might have legs, so we acquired a web accounting software product alongside us, AccountWrite, with basic bare bones functionality, and we call this Essentials. So we've got two ones now: we've got AccountWrite on the desktop and Essentials on the web. In 2012, we finally brought AccountWrite desktop to the cloud, so it's got its own server and cloud-hosted database now. But at that point, we thought, well, the web maybe, just maybe, might have a bit more of a future than Windows desktop software. So here was the plan. We'd build up Essentials, the new web thing, rewrite AccountWrite features one by one over 2 years into the new web stack, and then phase out the desktop. So great plan. We started adding features one by one using a cutting edge architectural technique that all the cool companies were using at the time, called microservices. There were a dozen teams fire hosing code into this rapidly growing ecosystem, and it grew and it grew. And we learned a lesson that many other companies have also learned. When you choose microservices as an architectural approach, you are spending a whole lot on complexity and tooling. There's a whole lot of expense and work and effort that goes with that. What you're trying to purchase is autonomy for your teams, autonomy in releasing. But you don't necessarily get that. If you've built a distributed monolith and you don't get those good things out of it, you're still paying the bill. 3 years later, we had reproduced just 15% of AccountWrite's functionality. We just hadn't built a productive stack. Putting a text field on a screen might take 2 weeks. At one point, a list and PDF screen took 9 months to build. This failure to deliver also caused the organizations to develop some cultural problems that kind of went along with it. Trust started to break down between product and development. And so product managers would feel lacking trust in the development team's ability to deliver. They would feel like they had to interfere in technical decisions and solution choices. And the software developers would lapse into being passive order takers without providing the necessary constructive pushback that they needed to. And this sort of stripped both parties of accountability and an ability to change the outcome. It was a bad situation. So this was the situation in 2018, a rich well of industry-leading functionality marooned in a Windows desktop product. 2 completely different and overlapping product ranges with no way to merge them and no really easy way to migrate between them. Multiple tech stacks where every feature and compliance update has to be written twice. So compliance is a big deal in accounting. Every time the tax law changes, you got to write software to account for it. If you got 2 stacks, you got to write that software twice. And we had a bare bones web app with the beginnings of a rewrite that would take a decade to complete. And this is in the middle of a generational shift from desktop users to online users. So if we miss the wave, what happens? What do you do in that situation? You would need to revisit your assumptions. You would need to rethink how you develop software, how your teams work together, how you approach things. And that's what we had to do. And that's the story I'm going to tell you here. So the plan, what do we need? Well, we knew we had to get to a single simple product lineup on a single tech stack that we could deliver like crazy on. When do we need it? We calculated that we would have to deliver this in a bit over 13 months in order to catch the wave of customers coming across. Now, this isn't a real graph. There are no numbers on it. The axes don't mean anything, but it tells a story. This was an urgent situation. So what do we do? The answer was right under our noses. We already had a mature, stable source of functionality, which was already being exposed as a server, AccountWrite. However, this was a huge decision to take, a big step. We had been pouring an enormous amount of effort and code into this other ecosystem for many, many years now. And so this was a huge change of tack. So we would have to redo the front end from scratch. We can't reuse the microservices essentials front end. It's too tightly coupled to all the implementation. And furthermore, because they're on completely different databases, a customer is either on one or the other. We can't do it incrementally. So unfortunately, this would need to be a big bang release up to whatever our definition of MVP is. Now, that's a big risk. So what do we tell people? Well, if we're spending a bit over a year focused on an internal replatform instead of customer-facing stuff, it's not really something you can advertise. People don't care about your software architecture. Customers don't care about your cloud topology. They want features, performance, stability, the usual things. So we decided to say, well, let's sell this as an upgrade. The essentials user using the web, they're still using essentials, but they've been upgraded. It's a new, improved web experience. It's on a completely different tech stack, but they don't need to know about that. That's not a customer-facing thing. For the desktop users, they get a new web experience alongside their desktop. So what this means is that a minimum viable product means we can't just reproduce what's there. We have to make it better. New architecture. We had neglected architecture in the past. This time we had to get it right. Now, the central concept here we came across was of a seam, a gateway layer separating the front ends and the back ends. So we can build as many front ends as we want on top. We can add them, we can remove them, we can modify them, and the changes don't ripple below. So these front ends or their BFF servers, they have to contact. They have to talk to the gateway layer, the seam. They can't talk directly to backends. Backends, we can add, remove, modify them, and those changes don't ripple up through the front ends. So we have that kind of decoupling, which makes it easier for us to work. The backends, they're not allowed to talk to each other directly. They have to talk through the seam. At the cost of some latency, this increases our level of flexibility. BFF, so many people have heard of BFFs already. This is a patent popularized by Sam Newman and Phil Calzado in 2015. And it's a kind of a server that exists to serve a front end. It soaks up all the logics of the front end, doesn't have to make as many decisions. It stops front end concerns for a given front end, like a mobile or a web or whatever, from soaking down into your domain server or gateway. And we decided to go with monolith and a monolith architecture. So we had proven that microservices weren't the answer for us. They might be the answer for you, that's fine, but not for us. Microservices have been around a long time, and it should no longer be controversial to say that they're not a good default. There's a particular set of circumstances for many companies where they might be a good solution, but that didn't apply for us. However, we all know monoliths are often terrible. We've all worked with terrible monoliths. We know what bad monoliths look like. So what does a good monolith look like? Here's something I tweeted at the time. 1 million components, but you only need to think about 5 at once. That's a simple system, 20 components, but you need to fit them all in your head all the time. That's a complicated system. Now the point in here that I'm trying to make is about cognitive load. If you're using a big monolithic system for a particular purpose, and all you have to do is to look at a certain small part of that system and fit only that in your head, then it doesn't matter how many other components there are on that system. It could be massive, and it doesn't matter. It doesn't matter because you only have to focus on a small part. And that's kind of what we wanted. We needed to have that here. We need our monoliths to be operable. We need to add a whole lot of functionality quite quickly, and we need to not turn into this thing that becomes exponentially more difficult to work with as it grows. There's a lot of stuff out there about modular monoliths. Usually they'll come with some kind of discussion about how you slice components. And I want to talk briefly about that. A common approach is horizontal slicing, where you have controllers, business logic, data access. I think we've all seen code bases like that. And then you add features. You have to add a blob in each of these layers. This has particular drawbacks in that anytime you're trying to do a particular thing, you're looking at the square blob here or the circle or the the diamond, but you're looking at a square alongside 100 other squares, which might be web controllers. If you're looking at a single domain thing, it's sitting there alongside 100 other domain things. It's just harder to tailor your cognitive load, the things that are in your head, to a small amount. And things that live next to each other in a code base tend to grow together over time. If you're using a particular piece and you're looking for a tool to help you solve a problem, and it's sitting right there next to you in that layer of the software, you're probably going to reach for it and use it. Things will start to grow together, and you don't necessarily want that. Cognitive load, potentially, there's no limit on the amount of cognitive load that you need to have to work in a horizontally sliced code base. Vertical slicing, it's not a silver bullet. There are trade-offs, but for us, this is what made sense. So this time the slicing is along a business area, could be invoices or payroll or whatever, and you build the tech things inside that layer. So build, slice, 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 slice. Every time you build a new feature, every time you build some unit of business functionality, it's separate. It's a separate thing. You can keep adding these new feature buckets without touching anything else. If you're modifying one of these feature buckets, you're just modifying that, and you're not modifying anything else. Merge conflicts are rare because a given team is usually working in one of these buckets, or a small number of them. It's highly cut and pastable. Cognitive load, ideally, you're just thinking about the thing in that feature bucket. So that's what we want. Doesn't matter how many other feature buckets there are, you're just looking at your one. Now, a challenge that has been made by Simon Brown is a completely valid challenge. One of the problems here is if you have orders and customers, you need to make a link between the two. Where do you go to make that link? Where do you put that customer? You can't put it in the order bucket. You can't put it in the customer bucket. So that is completely valid. In our particular case, we have an answer to this. First of all, you have to cut and paste between buckets. If there's some bit of code that's similar, we prefer to cut and paste rather than reuse. Secondly, feature buckets are not allowed to talk to each other. And we have a suite of convention tests that enforces this. If you accidentally have the invoice code talking to the general journal code or something, the build will fail. So you can't do that. Furthermore, there's a thin layer for shared code. So if you do need some particular code that needs to be used by more than one bucket, then it goes there. Now that's general utility code. That's not, I guess, domain code as such. Cognitive load, I guess, is kind of T-shaped now. It's the bucket you're working in plus whatever's in the core layer. We actually take it a step further. We have a nested vertical slicing pattern in these code bases. For instance, the general journal feature here, we see it has 5 endpoints: delete, get by ID list, next event ID, patch. And we have a separate vertical slice, internal vertical slice for each of them, and its own shared thing. So if you're working on general journals, say, that subtree of the directory structure is your world. That's where you live, that's what you're dealing with, and you're not looking at any of the rest of the code base. So here's our architecture that's supposed to take us to the promised land and let us do this improbable giant replatform and turn us around. We have 4 layered monoliths: a web, a BFF layer, a platform API, that's our seam, and a backend API that exposes account write functionality through this gigantic DLL with 4 million lines of code in it, where each of these new monoliths are vertically sliced, and each new feature will be just a blob in each of these code bases. So the answer to Simon Brown's challenge here is that all the really meaty links, the good kind of coupling, where orders need to talk to customers and that sort of thing, that already lives in the account write core. It's already happening. It's a sunk cost. So what we're doing here is building new software that's providing a pipeline from that to the glass. The odds were stacked against us. It's a huge amount of work. There's hundreds of features. Account write wasn't designed for this. There's a really hard deadline. We'd never delivered that fast before. However, there were some points in our favor, and that was crucial. That made it possible. We could reuse existing functionality. We weren't redeveloping this whole thing from scratch. And account write was surprisingly tidy. So we've got this big, ugly monolith that's over 10 years old and has had hundreds of developers pouring code into it. But it has structure that you can depend on. So we were lucky here. We had something we could build on here. And we basically knew the full scope already. So the focus of the project didn't have to be exploratory. We didn't need this big kind of explore, iterate, pivot kind of structure. We basically knew what we wanted, and we had to have a tight factory line, almost kind of production line approach. So the project, we divided all that work up into 407 features to be delivered by January 2020. That's on average something like 8 features a week for a year. Yeah, that's a lot of work. Team structure, we had teams, a small number of teams. So we insisted on a small number of teams, not a huge number of teams. Front end analysis, back end, and some gaps teams that performed upgrades onto the core monolith that were needed. Now, there are trade-offs with the different ways you can arrange teams. Here we've arranged the teams along tech layers. So we have a front-end team that are building up these new web and BFF monoliths. We've got an analysis team that's building up they're performing analysis, but they're building up the platform API monolith. And we've got the back-end teams that are building up the back-end API monolith and operating in the core. And then we have the core teams now. Now, why we've chosen this is because we need these code bases to be a productive base of development for years to come. We're not just knocking out a project here. This needs to be the fount of future productivity. So we want these teams to really own and love these code bases and make them nice and establish good conventions. The price, end to end, it's going to be more difficult. So the system of work at the start was something like this. The analyst would look inside the original monolith and go, "Ooh, what's in there? Let's have a look. Can that do what we want?" Deploy gateway contracts, and then front end and back end, they go do their thing, working off the gateway contracts. Then they deploy their stuff. One of them might finish earlier, and then they go on to the next thing, and then they're kind of done, and then it's done, or maybe, is it? Do you see the problem here? It's because these are tech-aligned teams. They're not they don't have a coherent view of end-to-end. Nobody owns the end-to-end feature. There's no sense of done that it really sticks here. The front-end team, they do their blob and they're done. Back-end job, the back-end team, they do their job and they're done. But there's no sense of actual doneness. So this is an inherent flaw with having teams shaped like this. You can mitigate it, but it doesn't solve it entirely. So anyway, 6 weeks have passed. We've done 1 feature. It's a start. It's a start. We'll need a functioning system of work though. So take 2. We needed to cultivate a kind of end-to-end focus here to compensate for the fact that we had these tech-layered teams. So we also took a bunch of ideas from Kanban and lean manufacturing to work on the cycle time and treat it as a functioning production line. So there was a tribe board that looked a bit like this. So a single feature might start off in analysis, and we write an A for every day that it's in analysis, and then it's done and it's waiting for kickoff. We write a K for each day that it's waiting for kickoff. Now, why is there a waiting for kickoff column? It's because we don't. It's a pull system. So when another team is ready to do their part of the work, they pull the work. It doesn't get pushed onto them. Now, the reason that's important is because you want to identify bottlenecks. You don't want to push work into bottlenecks. If there's a bottleneck, you want to put your resources towards resolving the bottleneck and making that flow smoothly. You don't want the team before the bottleneck overproducing work to keep piling work into it. That's wasteful. It doesn't do anything, and it doesn't improve the system overall. So having this waiting for kickoff, it means that the analysis team know not to overproduce, feeding into the delivery cycle. There's also WIP limits. So for instance, there might be a WIP limit of 2. If there's 2 features already in waiting, then they can't produce any more. Then they perform a kickoff, write the number of days they do the work. Now this time there's an integration step. So this is the checkpoint that is intended to mitigate the fact that the teams are tech layered. This time a different pair integrates it with the QA. We write I for each day there. Any rework that has to be done gets done by the original pair, but it stays in that column. It stays there until it's done. What we get from that is cycle time. In this case, that's 19 days of cycle time. That is one of the key stats we want to keep track of. So cycle time and throughput. Throughput is obvious. Throughput is how much we're getting done. Like there's some brutal maths here. We have to do 8 features a week or something to get up to the 409. That one's kind of obvious. Cycle time is a bit less obvious because it's not measuring how long people are working on the cards. It's measuring how long the cards are in the system. And it helps you find bottlenecks. It helps you reduce the work in process. It tells you, is our delivery system healthy? And the reason why that's good is because then that will improve our throughput. But it improves our throughput by doing less. If you're not tracking cycle time, you're just looking at throughput, the temptation is to do more, which so often does the opposite of what you want here. We've now done 3 features. We're well into January, and that's faster than 1 in 6 weeks, but we still need that needle to turn up at some point. Is it going to? Maybe. We keep working. It's now March. We've done 30 features. So we're starting to click. The new system of work is starting to click. We're starting to get a whole lot of throughput through. We're starting to build up confidence. However, we needed to adjust again because there was no way to project from there. We just didn't know where that was going to lead because all of the work was not a similar enough size. If the next one takes a month to do, is that fine because it just happens to be one of the hard things? Or is that bad because that's one of the easy things and we're bad at delivering? Well, we need to know. So we separated the work into a fast lane and a slow lane. So there's now 2 analysis teams, a fast lane team and a slow lane team. And now it looks like this. So we have the work separated into fast and slow, and now we can do accurate forecasting because we know that the fast things, they're the things that are just, we're taking the functionality verbatim from the desktop core. The slow ones are the ones where it needs customization to make it work nicely for a web situation. Cool. There are a bunch of trade-offs here that we had to make. If we zoom into analysis, each feature had a BA, a designer, and a dev working on it. The BA says, okay, well, here's the things we need to do. The designer says, well, this is what it should look like. Here's the nice web experience. And then the developer says, okay, well, let's look inside the account right core and see how we can do it, how we can leverage that functionality. But it often took the form of a kind of a slider. If the slider was down one end, then the functionality is very desktop-like, and that's technically very easy. We're just surfacing what's already there. But the user experience might not be that great. If we turn the slider up, then the user experience will be wonderful. It's all nice and customized for a modern web experience, but we might have to do a bunch of expensive customization in the back end. But that's not just shifting a slider. Each time you change that, it's a back and forward. The designer has to come up with new designs and iterate. The developer has to go back and do new analysis to find out whether that is going to be feasible or too expensive or whatever. So it ends up being a very, very costly back and forth. We really had to put that process in a box and squish it and find a way to cut it off in a way that allowed us to have repeatable, dependable work for this project. So this was a challenge. We're now in April. We've done 43 fast. We've done 7 slow. It's starting to pick up. The curve is starting to head up. We're gaining confidence. And where I talked before about that breakdown in trust between product and dev in the old system where there was poor delivery, that's starting to heal now. the organizational trust is starting to heal. Product managers are starting to trust that the development teams are going to deliver. The delivery teams are starting to trust that the product managers are not going to interfere and make a mess, and they're starting to pick up confidence that they can push back and exercise the influence that they need to. Now, there was another problem emerging, and that's that there were too many decisions to make. There was a bunch of technical decisions, this big throughput. And just like we had a big throughput of work to get through, a lot of them required a big throughput of technical decisions. But making a technical decision is work too. We had an architect and a principal dev, but they weren't enough to get through all that work. The historical shape of the company here had been that there would be a small number of towering architect, principal developer types who would know everything and do everything and be greatly respected, but they would be eternally busy, always fully booked and fully busy, and never have enough time to do anything. And then, even though we had a bunch of talented senior developers, they were always not ready, apparently, for leadership responsibilities. And there was this big gap, apparently, between architect and principal dev and senior developers that didn't look like it was easy to cross. So this was just a bad situation, but now we couldn't afford to have a bad situation. We needed it to work. And so we changed it. We made a new hat for every team had to select a tech lead, for one of their star performers. It's not an organizational role; it's an informal hat. And so we formed a tech leadership group then with these new aspiring tech leaders, meeting weekly to align. So this produced alignment among the technical direction among all the teams, and they go back to their teams and share the discussion and keep everyone aligned. It would allow us to share knowledge between the different teams. It meant that we could track progress on technical decisions and also mentor and grow these aspiring tech leaders. Then they could take that back to their teams and mentor and grow their teammates. And now we produced a situation where the decisions are now getting made at scale in each team, led by these tech leads. And the architect and principal developer then could play a supporting advising role instead of being a central choke point. So this is a wonderful situation. The decisions are higher quality because it's made by people where the work is, the people with the detail, not by architects and principal developers who are sort of spread too thin to have that insight, and they're getting made faster. So this is a really good situation. I say produce decisions, you'll notice there in the text rather than make, because that really tells the story about what's happening. When you say make a decision, it sounds like someone is just sort of pulling something out of the air. But that's not really what it is. Producing a decision is work. It takes finding stakeholders, finding technical experts, finding all the people affected by the decision, building consensus where there's division. It's work. It takes time to do that. And that's what these wonderful new tech leaders helped do. So this technical leadership group that we formed worked really, really well. It gave us alignment. It produced rapid growth in these tech leaders. They could exercise more influence. It broke the bottleneck. It was too much work though for the tech leads. So and it kind of distracted them from their teamwork. They already had a full-time job in their team, and I think the conclusion there was that we shouldn't have been trying to launder work outside of the org structure. That was kind of what was happening there. Producing decisions is work, and work needs to go through the org structure. But other than that, we learned from that. But other than that, it was a really great initiative. So now we're in July. We've got 96 fast, 23 slow, done, super duper. Now it was time to address the biggest risk in the program. The fact that we hadn't released customers yet, and we wouldn't properly release until January at the earliest. Now, that's a shocking risk. Now, there were particular reasons why we felt like that was what we had to do, but what if they don't like it? It's a huge risk. So what we did, we put together an early access program with a small group of trusted users that we had, customers that we had a close relationship with, and gave them access to the software as it was. And straight away, we learned a really valuable lesson. Users don't like half-finished software. Who knew? I think the V in MVP is maybe the most important letter. There were trade-offs to be made here too. So even though this was really valuable and great, it helped to de-risk the program and gave us a lot of confidence in the outcome, we couldn't treat the customers in the EAP like glorified beta testers, because even though that was what they nominally signed up to, they're still customers and they still want things, and it still affects our reputation if we don't give them certain things while they're doing that. And so it became a new source of requirements, a new source of complexity for the project in a way that was sometimes kind of distracting with the production, super efficient sort of production line thing that we were trying to do. So we had to find a sweet spot there and control that. Cool. We're in October, 194 features fast, done, 39 slow. So slow is starting to go sideways now. The fast lane's going well. So better keep an eye on that. It's now December. It's almost at where we wanted to be. We wanted to release in January. We're traveling well for fast, but the slow is really slowing down. Now, at this point, we have to change our system of work again. This time, now the analysis is done. The analysis teams have wrapped up all their analysis work. Normally, you don't want to do this in a project because it's work in process. It means that you've got a big pile of work in process that's probably going to be waste. You normally want to do analysis sort of roughly at the same time as you're doing the work. But in this case, because we had so much certainty around the shape of the project and the scope of it, this was something that we were able to do. So now this freed up a whole bunch of developers to leap into the writing software, which they were very, very, very happy about. So what we did is we formed new vertical teams now. So that they might be working on some particular area of the software, like payroll, for instance. But we also kept our existing front and back end teams. And there were some interesting trade-offs here too. The horizontal teams, now the reason why we kept them together is because they were hardened performing teams. They are really, really well gelled. They know each other really well. They're working together really well. And blowing them up is a really risky thing to do at this point. It's going to, any new teams are going to take a while to build up into a forming, norming, performing, it'll take a while to get into that performing state. However, there was still that end-to-end incoherency that comes from being horizontally layered. And this led to a certain rate of defects, even mitigated by the integration checkpoint. However, having vertical teams introduced a new custodianship burden, which added a considerable stress to them because they didn't have any allocated time to manage that. They were still supposed to be pumping out features at a really fast rate. On the other hand, the vertical teams, they were fresh and kind of storming and thrashing around, trying to find good patterns and trying to learn about each other and work together well. They were super, super busy-lined, but they were bad at tech patterns. They needed that custodianship work. So this was something we had to thrash through in the last few months. To get to the finish line, we had to do three things. We had to make the delivery manager cry, we had to make the product manager cry, and we had to make the architect cry. And having done those three things, we got there to a state of feature completeness in February. We hardened it for 4 weeks, and in March 2020, we released. We did it. We did it. All that effort, all that work, all that stress, we did it. but now what? But now what? Because we had released to a very, very small number of customers. All of the existing Essentials users were still using that old stack. The desktop users hadn't seen their new browser yet. So we were really releasing just to the brand new customers. They would see the new experience. And so that would that pool of users would expand at the rate of customer acquisition, but it was still quite a small pool of customers. So we had a lot of migration work to do. The next 6 months were going to be crucial. And here's how that went. We First of all, we brought in heaps more developers. Now it was time to turn the entire SME part of the business into an organization that was working on this new tech stack and drawing value and being productive on this new tech stack that we'd built. So we turned a whole lot of our developers and brought in all the other parts of the SME and turned them into vertical teams operating on this code base. And you'll notice here I'm using a different language now. I'm calling them streamlined teams. And the developers that operate on that complicated account write core, I'm calling them complicated subsystem teams. Now, the reason for that is that in 2019, Matthew Skelton and Manuel Pays wrote Team Topologies, a fantastic book that I recommend you read, and everyone seems to be talking about it. I proposed a drinking game that you could take a drink every time someone mentions it in the conference. I'm so far the only one who has, so let's see. It might be a moderate and sensible afternoon after all. So the streamlined teams are aligned to a flow of work in the usual way that many teams are. Complicated subsystem, that's self-explanatory. A platform team is a particular kind of team that is operating a platform for the benefit of other teams in the organization. Now, this is kind of what we wanted now because we had a platform now. It's not just a project. This blue part of that diagram, that's now a platform that's supposed to allow super productive development of different front ends on top of, or back ends behind. But to start with, what we did is we gave custodianship responsibilities to some of our vertically operating teams. Now, what made this work better than before, when we had these super strained front end and back end teams, is that now they officially have 20% maintenance time allocated. So they had a proper allocation of time to do that. And the complicated subsystem teams, of course, they had custodianship for the core. Now, there is mitigation still to do because streamlined, so vertical teams have disadvantages, just like horizontal teams have disadvantages. Streamlined teams, you get that business alignment and end-to-end sort of delivery autonomy and that sort of stuff, but you don't get alignment between them by default. But by default, they'll all just drift off in their own separate directions and just make big mud puddles in a microservices architecture. That's fine. They can go make mud puddles in their own area, and that's fine. If we're all living together in these shared monoliths, we need alignment. So we had to create communication structures to build this sense of aligned autonomy. That's the buzzword that we wanted. We want teams to be autonomous and mostly doing their own thing and delivering rapidly. But we need them to be aligned. And so we had all these overlapping communication structures. So the tech leadership group, we resurrected that and now made it across the whole SME part of the business. And now just as an alignment group without sort of using it to drive work, we created this new concept of an architecture group, which is roughly a kind of a working group just focused on that area of technology, web, platform, account write. So all the people working on a particular part of that platform can have a regularly meeting group where they can align on that and make sure they're all doing things the same way and share problems and solutions and that kind of thing. Now, the overlapping part of it is important. If you have completely orthogonal communication groups that don't overlap, it means that you can get disjointed work. You can get a kind of a breakdown in alignments. Having slight overlaps means that it sort of forces people to care about each other's work. It also creates communication redundancy, which helps build this kind of pervasive frame of reference. And that's what we want. We don't want to rely on documentations and written down rules and this kind of thing. We want to have aligned autonomy across the board. We want this kind of pervasive knowledge to just be in the air you breathe, and you breathe that air and it's just like, oh, well, everyone knows we do it that way. Oh, is it written down somewhere? Well, maybe, but we just know. So this is having these really well-functioning groups means that we can mitigate the risk of these autonomous teams drifting apart. Now, the internal tech leadership, the growth and culture of growth and culture of tech leadership that came out of what we did in that project meant that by mid-2020, we had promoted 6 developers to principal developer or architects. So our efforts to promote tech leadership really worked spectacularly. We broke that cultural problem where there was this big gap between the leaders and the mass, and there was no way to jump up between them. Now there's a pipeline, and there are ways to grow. There are ways to exercise influence. There are ways to do more than just what you're assigned in your particular team. And so where to from here? So now we are in a position where we really have a lot of options. We can write more front ends, we can write more back ends, we can change our product lineup as we please, and the technology will support what product want to do with the product lineup instead of shackling it and binding it to the limitations of the technology. We want more and more team autonomy to make this work on our monolithic architecture. Now, there are certain limitations to how autonomous teams can be on monoliths. You know, you won't get that super fast deployment that you get with microservices. There's always going to be this element of everyone lives in a shared building, like a shared apartment building, and people have to look after it. So we're massively investing into developer experience and build and deployment tooling to make this a nice experience so that developers can work across these different code bases and do that effectively and efficiently. We're now delivering software faster than we ever have before coming out of this project. Will we introduce microservices in the future? Well, maybe. We could if we wanted to. We probably won't though. It's not about the micro, it's about the boundaries. And we'll continue to add services below the seam as appropriate. And we have a lot of freedom in evolving that now. So we won with the right people, the right decisions, good leadership, the right trade-offs. Difficult things can be achieved. We started with a crisis that had the potential to cripple the company, and we had to completely reinvent how we delivered software in order to get over that and to put us into a better position. And we did that. The project was a complete success. The last user on the old Essentials stack will be migrated to the new stack shortly. We've almost completed that process, and it will all be fully, every customer will be fully unified on this new stack. We're now in a much better place for both developing our product and tech in the future. Now, that said, we were in a horrible position and we had to take a risky, stressful project. You don't take a project like this unless you're in a horrible situation. It took a big toll on the people involved just because of the level of stress and the level of importance, I guess, and criticality of it, and the tight timelines. And I think everyone involved is terribly proud of the result, but this isn't a situation that you want to repeat. What you want to do is to never, ever, ever be in that situation ever again. So you don't have to do a project like this. So don't do this at home. Even though it was a big success, we all said never again. We never, ever want to be in a position again where we need to take a project like that. And that's important. I want to leave you with this thought. High stakes don't mean overtime. Now, I don't want to say that overtime never happened. There were times in teams and situations where people did overtime at different points, but overwhelmingly, the project was based on an assumption of a standard 40-hour week for everyone. 40 hours was the norm. That was what the planning was based around. Those projections that were driving the project that were based on data. They were data-driven projections. They weren't ambitious, sort of ambition-directed, ambition-fueled, made-up projections. And that was based on a 40-hour week. So instead of, when we were under pressure, instead of putting the blowtorch on people's time, we put the blowtorch on tuning prioritization, all driven by data, dropping scope, tasteful technical compromises where it belongs, instead of burning up people. And that's the talk. Thank you for your time.
That was fantastic, Ken. What a great story to hear about a project like that. That's pretty massive. Okay, so hitting up the Q&A. If you haven't already, jump in, fire up your questions. First one is from Reese. How did you go about mentoring the upcoming tech leads? Was it organic or structured?
Oh yeah, I'm glad you asked that question. So I did a whole YOW talk on this 2 years ago, which was actually at the time during that project. So I recommend you go and let me just go and recommend my own talk, growing tech leads. So the mentoring was, first of all, it's the senior people, we booked regular mentoring, like one-on-one sessions with a lot of the individuals, but it was also these group meetings. A lot of that was about setting a culture and the kind of conversation that we had. And so for me, I would, the things I'm doing is I'm encouraging them to have a culture of openness, a culture of teaching other people and to putting other people first and growing their people, and not simply being excellent people themselves, but spreading that excellence and growing that. And then comparing notes by advising how to handle particular situations with personalities and that sort of thing. And just providing that cultural atmosphere to absorb qualities of leadership and what works and how it's good for your teammates and that sort of thing.
Cool. The next question is from me, which people have been foolish enough to vote up. So putting my little tester's hat on, in my experience, the monolith is an automated testing nightmare. So how did you manage that and CI/CD kind of things effectively?
Yeah, it's a great question. So, the core monolith that's based on the old desktop stack is a difficult thing. So that's historically that's released quite rarely, and all the quality tests, all of that stuff takes a long time to run. And so that was a place where it was expensive to make changes. But the new stacks, we made sure that we could have rapidly or relatively rapidly running tests. So for the front end, the BFF, the gateway, and the back end API, we had to really take a pretty firm line against these sort of clicky end-to-end suites, which are kind of seductive, but they end up frequently not really delivering and just making everything take a long time and really not giving a true sense of quality or confidence. We also use contract tests to using the Swagger API documentation so that we could have that build up that kind of confidence between these layers, that the way these different layers were talking to each other. The aim was always to shift quality to the left. So we had to really fight to stop it turning into this kind of late stage, okay, everyone, throw the code over the fence and then all the QAs hammer it. We had to really shift everyone out of that mindset, move the quality to the left so that everyone has a responsibility for quality and everyone takes the approach that this code could be deployed at any time.
Cool. Next question from Richard. The strategy undertaken seemed to contain a lot of repeated work, which is often a breeding ground for pattern creation. Were there any key team, process, or code patterns that you discovered?
Okay, yeah, creating patterns. Well, the vertical slicing that I talked about in that part was a really key part of that early pattern setting, which meant that we could, the act of adding new features could be a very repeatable kind of predictable thing. how much detail do I want to get into? There's, yeah, I mean, yeah, I guess it depends what kind of level of detail you want there, but there are many. Do you mean, is that like technologically or process wise, or?
I think it was people / process / tech. So
yeah,
maybe
sure.
it's a lunchtime side conversation that's going to take the full hour.
Yeah, maybe, but it was a process of iteration. Like the tech and the process went together. And I hope that came across in the talk there. It really was a socio-technical kind of fusion of things, and we had to iterate that whole thing as a socio-technical whole constantly, the way the architecture fit together and the process by which the work went through the system and by which the teams interacted with each other. So that whole thing as a socio-technical whole had to be continually tweaked and tuned according to the data that we took along the way. So that was how we went about that.
Cool. Next question from Ashley. How do you scale the monolith? That's the main benefit of microservices, ...
Yeah, for sure. You throw 10 at it. There's a bunch of instances. I mean, the hardware's cheap. Yeah. I think, yeah, it's not hard if you've got a single thing, and it's not too hard to add more and more instances as long as the software is amenable to that concurrency. Yeah, there are certain bottlenecks, like the database. We had to do a whole bunch of investment to make sure that there were fewer bottlenecks around some aspects of the network usage and database usage and that sort of thing. Yeah, I think, I mean, microservices are not a get out of jail free card here, because there's a lot depends on the way that the microservices are talking to each other. Like a single microservice, fine, but the whole ecosystem of microservices, you're potentially dealing with a whole bunch of other stuff depending on how you've set it up. So yeah, neither way is resistant to scaling, and neither way is a silver bullet.
Next question is from Adam. With such a hard deadline, how did you manage stakeholder expectations and workload for BAU versus the program delivery?
Yeah, great question. The executive team were incredibly nervous about this whole thing, because everything depends on it succeeding, and there's nothing they can do. Like once the project started, all I can do is look at it and sweat. That was difficult in the early stages, because at the early stages they were like, okay, we've made this seismic decision to completely change the tech stack. Have we made the right decision? Do we need to do executive things and stop it and intervene and do this and do that? And the management of the delivery team had to do a lot of upward management in those early stages to sort of protect the team from that sort of intervening impulse, because of the level of nerves that they had. But then once a few months had passed and we started to really build up a delivery cadence, and it became really apparent that we knew what we were doing and we were really delivering software. That kind of stuff went away, and we didn't have to worry. Like the leaders sort of said, okay, well, let's let them do their thing. Yeah. So it needed some upward management from the delivery managers at start, but then once we build up the confidence through delivery, that went away.
Next question is from Ed, who says, can you give any examples of fast and slow work items? Or is that secret squirrel?
Yeah, no, I can. I mean, what made it fast or slow essentially was if it's similar to what the desktop already does, and just surfacing that functionality up to the web interface, if that is an okay web experience, then that's easy. That's a fast lane item. If one needs particular customization because the desktop UI experience doesn't work at all in the web scenario, which is something that often happens, and it needs particular customization, and especially customization in that big, complicated account write core, that's going to be a slow lane item, because we can't exactly predict how long it's going to take. Like, if once you're in that core, could be easy, could be hard. So specific example, I don't know, but it's going to be things that have really advanced modern web workflows, and things like I don't know, things that need really nice workflows, like oh, actually no, I'm not even going to guess. I won't give concrete examples, but that's the main sort of factor that determines that.
Next question from Karen. At what point in your project did you feel you could have done things differently or better to ease that stress on your people? And what prevented you from taking steps in hindsight?
Yeah, that's a good question. To an extent, it was unavoidable. Like, fundamentally, what we had to do was something that was very difficult and challenging. Now, as I've said, the source of the stress was not people had to work overtime like some video game company. Overwhelmingly, it was based around a normal office hours. The pressure came from well, I guess people talk about mastery, autonomy, and purpose as the three things that people really get motivated by. Mastery was maybe medium. So most of the developers were in these tech layer teams where they can grapple with this the same technology consistently, and become experts at that. So mastery was okay. Autonomy down the bottom. So we had to be cooped up in this factory line kind of shape, because that was just what the project needed. We needed this fast, robotic kind of cadence with work items that look as similar as they can possibly look, coming, going down this pipeline. And so people had these really tight, like, they had to be producing so much a week according to these patterns, and they didn't have a lot of room for creativity or coloring outside the lines. And that was, it's kind of exhausting doing things that way. And then purpose was off the charts. Like, the mission was just really, the sense of mission was really, really high. So it was that lack of autonomy was I think the big thing. And then a whole bunch of, I guess, if you increase the level of pressure, then people are kind of bouncing off each other in different ways with a higher level of velocity and that sort of thing. What could we have done? I think we did well to get it as good as we did. I think that in hindsight, I don't know, we probably could have better tuned the way that the teams were working together, and so some of these things like the custodianship thing, where the teams were getting hammered with custodianship burdens as well as feature delivery burdens. Like, handling that, catching that up front, and saying, okay, well, let's rejig that to make that more sustainable. There's a bunch of little things like that. Like, I could go into a bunch of detail. Maybe that's where I'll stop.
Okay, getting ideas for the next talk. Okay, one final question before we break off for lunch. So, how is upgrading core libraries in infra, e.g., .NET 5?
Yep. So we're going to upgrade. That's not a very easy thing to do. So it's going to be a bit of a task, but it's something that's coming up.